In our quest to make software faster, cleaner and more scalable, we sometimes forget that we're making it difficult to explain that code to our future selves. Now, CQRS is one of those ideas. It makes perfect sense at the time, but down the track you may wonder, was it worth it? Well, in today's video we're going to do a full CQRS build, all the way from taking a standard API and implementing CQRS in that API, and you can then maybe decide for yourselves whether CQRS is indeed worth it. Well, hello, wherever you are, whenever you are. Where am I? I'm in a shed in Kent in the UK, and when is it? It's August 2025. Well, this is a video I've wanted to make for quite a long time, and I've had a few people asking about making this video as well, so I've finally got around to doing it. And what is it? Well, today we're going to be talking about CQRS, or Command Query Responsibility Segregation, which is a bit of a mouthful. We'll go over what that is in just the next section, but for now, sit back, relax, and enjoy the video. If you like it, please give me a like. If you haven't done so already, think about subscribing. But if you can't be bothered doing either of those things, I'm just happy that you're here with me, watching and hopefully learning about CQRS. So coming up next, a little bit of slideware before we jump into the full step-by-step build. So yes, today's video is CQRS in .NET, a full step-by-step build. So this is what we're going to cover in the video today. What is CQRS? Core concepts in CQRS, but we're really going to focus on those as we build the code out. We'll just cover them briefly in slideware, don't worry. Benefits of using CQRS, when and when not to use it. We're going to do an evolving build. So what I mean by that is we're going to take a non-CQRS API and we're going to evolve it and introduce different concepts as we go, layering them up and doing it that way. So yes, here are our build stages. So yeah, we're going to do a base build, simple minimal API, no CQRS. We're then going to implement a very simple example of CQRS ourselves, no additional frameworks or anything like that. We're then going to evolve that model a bit further and just make it a bit more enterprisey, a bit more maintainable, all that kind of stuff. We're then going to add validation, so not unique to CQRS, but it's very important within CQRS. We talk a bit about the validation we're adding here in our handlers. Section 5 is really more about just embedding what we've done, and this was a question I had when I was starting out with CQRS about how you structured your app. This section is really answering one of those questions about adding additional handlers, basically. We're then going to move into, for me personally, all this stuff, sections 1 to 5 are interesting enough, but for me where it really gets very interesting is section 6 onwards. That's when, it's a slow burn, this one, to be honest with you, and it's section 6 where it really gets more and more interesting. So section 6, we're going to start emitting events, and then section 7 is a big section, but it makes sense to put all this stuff together. We're going to split our databases into two, one for reads and one for writes. We're going to talk about something called projections and eventual consistency. And then the final section, all of this stuff, sections 1 to 7, is all code that we write. Okay, there's no external packages or anything like that, but if you've thought about maybe implementing CQRS in .NET, I'm sure you've heard of MediatR. It's an external package that you can use to do a lot of the heavy lifting, and we talk about that in section 8. And we actually implement our application in MediatR as well. We swap out our self-rolled bits for using MediatR, and it's actually quite an interesting section as well. So these are the ingredients if you want to follow along with me today. I hope you do. .NET 8 SDK you'll need installed. To be honest, you can use anything from .NET 6 upwards, and obviously the latest version at the time of making this video is .NET 9. I'm sticking to long-term releases, so I'm using .NET 8. Any text editor really doesn't matter, but VS Code has kind of become the de facto standard these days, and I highly recommend it. It's a great editor. And in MediatR, as I said just in the last slide, we are using MediatR later on, so if you want to use that you can, but you absolutely don't need to. Alright, so what is CQRS? Well, it stands for Command Query Responsibility Segregation. It's a bit of a mouthful, and it was born out of the Domain-Driven Design movement, or the DDD movement. And fundamentally what it is about splitting the model for reads and writes. That's basically it. Okay, so that's it in a nutshell. We optimize the app for reading and writing. Okay, so we talk about commands, which are related to the writing component. So creation, delete, and update. So commands modify data, and queries retrieve or read data. And yes, really, it's ultimately about optimizing complex systems where the read and write workloads are strategically different. Okay, well, I've got a couple of examples just to kind of illustrate that point. So some core concepts, I've already mentioned commands. These are actions that modify system state. So think of something like do this. Okay, I want you to do this, like create an order, which, so, spoiler alert, is what we're actually going to be doing in this video. Very simple e-commerce kind of idea. Queries, request, are requests to retrieve data from the system. They do not modify system state. So think about, tell me something. Okay, fairly straightforward. Okay, so the write model is responsible for handling commands, updating the data store, and the read model is responsible for handling queries and retrieving data. So we're going to talk a lot about handlers in the video. Okay, we'll be writing handlers, and we'll be designing commands, and we'll be designing queries. And that'll become a bit more obvious when we move into the code. What are the benefits? So scalability. So commands and queries can be scaled independently, allowing for a more efficient handling of workloads. Maintainability. So I've kind of said maybe on this one. So separating the concerns, which is definitely what you do with CQRS, makes the code more modular and possibly easier to understand. It really does depend on personal opinion, to be honest with you. And sometimes I feel that this type of thing does achieve that, and I think other times it is more complex than is necessary. Flexibility, different data stores. I do like this one. Different data stores and technologies can be used for reads and writes, but actually not technically CQRS. So we cover this in the build, but CQRS is really about architecting your application, the internals of your application. We do this in the build. We actually take our central singular data store and we split it into two separate data stores. Okay, that act is not technically required of CQRS, but it's often done. Because if you're going to the trouble of optimizing your application to perform reads and writes in a very separate way, then for me it makes total sense that you would optimize physical data stores to enhance that as well. Okay, and you might even have, as it says there, totally different paradigms. You might have a SQL data store for reads and a NoSQL data store for writes, or the other way around, or two different relational database systems. We're not going that far in today's video. We're just using SQLite. And we're not doing any database optimization or anything like that, but we're just splitting the data. But yeah, I do actually like this benefit. Performance, yes, focus concerns often lead to optimization for both reads and writes. And again, for me, it's really the last two I actually think are the real benefits for me. Performance is really the one that you'd be looking to drive. So when to use CQRS? I've already mentioned this. When there are significant differences in read and write workloads, that's probably one of the primary reasons when you would choose to use it. This one is also right on point when the system needs to scale to handle high traffic. This next one is interesting. Complex business rules should be abstracted. What we mean by that is if you've got a very simple CRUD, create, read, update, and delete API that's just reading to a database and writing to a database, and it's not that high traffic, that's a fine pattern to use. You wouldn't use CQRS. But if you had complex business rules that needed to execute before you wrote something to a database, say like creating an order where you might have to check multiple systems before you create that order, that's when you're starting to think, maybe we want to decouple that business logic and not have it embedded directly in our HTTP concerns, in our endpoints, and have it maybe handled by a handler or something like that. Okay, so that's what we mean by complex business rules being abstracted out. I really love this one when you've used it before successfully. So if you've been in a project team and you've built an application and you've built it with CQRS baked in from the start and it's been highly successful, or you migrated to a CQRS pattern and again it was highly successful and it delivered a lot of benefits, then absolutely, why wouldn't you go down that path again? Okay, of course, it's a very compelling reason. If you've done it before and it worked well, you should absolutely look at doing it again. So let's put it in a bit of context around some actual examples. So again, when I was learning about CQRS, I struggled with the value proposition. So let's talk about e-commerce, which is really what we're going to be doing in this video. So why it fits as a pattern. High volume of product browsing. Okay, so you get an e-commerce site, lots of people doing reads, product searches. It's a particular type of workload versus fewer purchases. Okay, so you might have hundreds, thousands of people viewing products, but maybe only tens or hundreds of people buying products. Very different read and write workloads. And in the case of orders, they are complex, potentially very complex write operations. Okay. So as it says there, product catalog will be read optimized, order processing is write heavy and potentially very complex. So definitely suits CQRS. Second use case would be financial systems. So why this fits, highly secure and audited write operations. Okay, so transfers, deposits, all that kind of stuff. Again, complex stuff. And the requirement for real-time balance inquiries or statement generation. Okay. So when not to use CQRS? Most of the time, okay? And so you might be going, well, this is a video, why should I invest my time in watching this video when you're saying most of the time you shouldn't use it? Well, I'm being honest with you and I'm being upfront with you. I wouldn't use it most of the time, but there may be times, as I already said, where it would be useful to use it, and so that's why it's useful to learn about it. Definitely overkill for simple CRUD-based applications. I think it definitely increases the complexity. And as engineers, when we are building software, personal sort of viewpoint of mine is that we should keep things simple as possible. Okay, not overcomplicate. Anyway, that's enough slideware. Let's get to the main event, and let's start our build. Start coding. All right, so let's get started with our minimal API build, the base build. So this part has nothing to do with CQRS. It's just a standard API. Built in a very simple, exceedingly simple way. Okay, so you can see the architecture on screen here that we're going to be building out, and we'll evolve this architecture, of course, throughout the video, and you'll see the differences at each step on how we're going to build it. But for now, we're keeping it simple. This is our very basic minimal API, and two endpoints, a post endpoint to create orders and a get endpoint to retrieve a single order. We have an order model, which is an internal representation of our data. We have a DB context, and we have a SQLite database. And that order model is represented down in our database as a table called orders, which will one row per order entity. All right, super simple. And what you'll see here is that these HTTP endpoints are actually accessing and using the DB context to do the data manipulation and do other stuff as well, potentially. And I've also got the dependency injection container visualization here, so we just have a DB context registered. The reason I've included that is as we move through the video, you'll see all the different services evolve as we move forward, and it just helps, I think, understand what's going on a bit better. Okay, so let's move that off to the side. Let's get started with our build. So I'll bring up a command prompt. I'll change into my working directory. Make sure there's nothing there. No, there's not. And we'll just check that we've got the .NET SDK installed. So .NET --version. I've got 8 installed. 9 is the current one at the time of making this video. So use 8 or 9, but to be honest, version 6 up is probably fine. It's cool. So we'll create a project. So .NET new. We'll use the Web API project template, and we'll call this orders API. Now we'll go away and scaffold that up. Quick directory listing, we'll change into that folder, and we'll open this in VS Code. Fantastic. Okay, so I've got a couple of extensions installed here. Actually, just 2, but one really that you need to use, which is a C# language extension, and I've also got personal preference material icon theme as well, but that's absolutely just a visual thing for the display of the folder icons. And you get this .NET install tool when you install the C# language pack. But yeah, this one's the one you need. Anything else is optional. Let me make this a bit bigger actually, so you can see stuff a little bit more clearly. And over here is our project. Out the box you get a very simple API, it's just random weather data. So let's test it to make sure it's working. So I'll bring up a terminal in VS Code. On a Mac it's Command backtick, and on a Windows PC or Linux it's Control backtick. And we'll just do .NET run to run that up. And the reason I'm doing this is just to make sure that there's nothing peculiar with our environment and the SDK is installed correctly and all that sort of stuff before we go into our build and encounter any weird errors or anything like that. Looks okay, so we've got this one HTTP endpoint. I'm just going to copy that for the moment. And I'm going to use a tool called Bruno to actually make the API call. Bruno is just an API client in a similar vein to Postman and Insomnia, tools like that. You can use, of course, anything you like, anything you're comfortable with. I'm using this because it's very simple, it doesn't force you to log in or push stuff up to clouds and stuff like that, so I like it. And it's got great GraphQL support as well, which is not relevant to this video, but I do a lot of GraphQL stuff actually, so it's good for that. So come into here, development, and into Bruno, and we'll create a new folder for a collection. We'll just call it CQRS. Create that, open that up. That's cool. So that's our collection created. We'll create a new request, and we'll say get weather. It's just the name of the request. We'll paste in the base URL and then come back to the code to get the route. So there's this one endpoint in here that just gets our weather. Let's just copy that, paste it in here, create it, and then we will run it. Let's run it, and we get our weather. Okay, so again, the reason I'm doing that is just to make sure everything's working. That's cool. So we'll stop that from running, and we're going to clear out a lot of this code here because we just don't need it. So leaving the first line, but we'll take out lines 3 to 6. This is Swagger. As useful as it is, we're not using it today, so I just want to clean it out. Lines 5 to 10, take that out as well. Actually, if you bring up the command prompt, you'll see actually when we ran that, we got a warning. And what it was warning about was that this line actually ran, or this policy ran HTTPS redirection. And what that means is when we hit a HTTP endpoint, it tries to route it to an equivalent HTTPS endpoint. There isn't one, of course, we're just running on one endpoint. And that's why we got the warning. Now I'm going to maintain that. I'm just going to keep running it as HTTP purely because that's just a tutorial. Of course, if you're deploying services into production, you should use HTTPS always, always, always. But I'm just going to keep it simple today and not use that. So with that in mind, I'm taking this out because there's nothing to redirect to, and I don't like warnings. We don't need warnings. Take that out. We'll take out the endpoint. We're not going to use that either. And we'll take out this record. Okay, so all you should actually have is 3 lines. Okay, these 3 lines maintained. Save that off. Get rid of this again. Then in properties, in launch settings JSON, I'm just going to tidy up this file here. Take out IIS settings. I'm going to leave HTTP profile. That's the one we're using, but I will clear out the launch browser and launch URL. Don't need those. And then I'll take out these remaining ones here. Now just be careful when you're deleting brackets and all that stuff that you still have a valid JSON file. Okay. Again, you don't really need to do that. I just like doing it to trim out anything we don't need or aren't going to use. And then finally, in terms of clearing out, in our CSproj file, let's just take out these package references to OpenAPI and Swashbuckle. Don't need those. Save those off. Fantastic. So that's our kind of basic API cleared out, ready to actually start coding. So let's get on to that. So the first thing we want to do actually is add a couple of packages. So let's just bring up our command prompt again. Let's clear that out. So it's .NET, add package, and it's Microsoft. .entity. Framework core, all one word, and then SQLite. And there's not 2 L's, there's only 1 L. SQLite. And that should go away and put this package in, assuming I've not made any mistakes. No, there it's there. Cool. Up key, and then take out SQLite and then just pass in design. You need the design package as well. Perfect. Looking good. Okay, cool. So we can get rid of that for the moment, get rid of this as well. Next thing we're going to do is create our model. So new folder, call it models. And into our models folder, we're going to create a file called order.cs. And you can see, or you will see as I move through the project, I'm taking a technology approach to structuring the project. And what do I mean by that? I mean, I'm going to use technology terms for the folders, so models and data and commands and queries and handlers and all that sort of stuff. You could take the other approach, or one other approach, which is a feature approach, where you'll see things segmented by the features in your application, so orders, products, you know, all that kind of stuff. But because this is a technology tutorial, I'm structuring it in a technology way. It's also the way I typically do it. And we're only going to have very simple features, so it doesn't really make sense to do it in that way. But just calling out, you could structure it differently if you wanted. All right, so our order model is going to be super simple. It's just a public class called order. Okay, and with a few properties. So if you type prop tab, the first one is an integer, so we can tab over, call it ID. It's just the identifier or order, and that will be the primary key in our table as well. Prop, this one is a required string, small s, and it's going to be called first name. So this is just the first name of the person who created the order. Prop again, tab again, a required string. No guesses what this is going to be called. Last name, that's right. Prop again, required string, and it's going to be called status or status. Now you're probably using the enumeration here, but again, can't be bothered dealing with that right now. Just keep it simple, have a string. Next one is a date time called created at. Cool. And then last one, prop, is going to be a decimal, and I'll call that total amount. Total cost, let's say. Total cost. Alright, very simple, no line items or anything like that. We just need something to represent an entity, okay? Don't need to get too caught up in whether it's a perfectly formed data model. It's definitely not. Next thing we want to do is a database context, so a new folder, and we'll call that data. Into that we'll create a file called app.dbcontext.cs, public class called app.dbcontext, which inherits from a base class called dbcontext. So error, so cursor anywhere in the offending article, controlling period to bring up our quick fixes, and we'll select the first one. New line, and then CQRS to tab, then to create our placeholder constructor. Tab in, and I'm going to pass in DB context options. DB context options of what type? App DB context. I'll call that options, and yeah, that's why it's giving a little bit of an issue there. So app.db context, that's better. Now let's finish this off, and that's from the base class. It's options as well. I'm trying to type fast, and I find as I type fast I make loads of mistakes, but anyway, we'll uncover those if there are any. That looks okay now. And then all we need to do now is create a DB set to represent our orders down in our database. So property, tab, DB set of type order, or order entity, and we're going to call it orders, plural. Okay, and that basically will manifest as a table down in our database. I'm going to set that to not null. Okay, that. Cool. Alright, so that's our model, that's our DB context. The only other thing we need to do, or a couple of things we need to do, is create a configuration string or a connection string to our database. So we'll come into app settings JSON, create an entry for connection strings. We'll call this base connection or basic connection, and then the value is data source equals, and then it's just a path to a file. SQLite is just a file. If you were using something like SQL Server or Postgres or something, you need a server set up and waiting, and you need a more complex connection string with ports and host names and all that stuff. SQLite's just super simple. So you could pass a path if you wanted to put it in some other folder. I just want to create the file in our root or project. So it's just a file name. So no CQRS.db. That's it. Fantastic. I'm just going to copy this value here, base connection. Save that off, don't forget to save it. Back in our program class, we need to register that now in our DI container, if you remember. So we do that by accessing the builder, accessing services on the builder, and it's going to add DB context of what type? Not app DB context. Then I'll pass some options into that. So options, go to options, and we're going to use SQLite here. And that expects a connection string. So we could just actually hard code a connection string, but since we've gone to the bother of putting it in config, we'll pull it from config. We do that by accessing a builder, accessing configuration, using the get connection string method, and that just expects the value of the connection string key, basically. And we'll just put a semicolon there. So base connection, coming back in here, it just expects this value, and then this is what it needs, the actual connection string. Fantastic, so hopefully that made sense. Again, I'm rushing through this quickly because, again, I think I've said before, I'm assuming you know about APIs at least a bit, and the main thrust of today's video is CQRS. Some of this stuff I'm going through it a bit too quickly. Maybe check out one of my other videos and I go through it in a lot more detail, a lot slower, and we do things like DTOs and all that stuff as well. And then all we mean to do is to create some migrations or create a migration and then populate our database. So the way we do that is .NET EF migrations add, and we'll just call it initial migration. Now this EF keyword here is a set of tools for Entity Framework. I don't believe they come installed by default with the SDK. You'll need to install them. Additionally, I'll flash up on screen the command prompt you'll need to type if you want to install those, which you'll need if you want to run migrations, of course. And the other thing here is capitalize your migration name. If you don't do that, certainly a while back I didn't capitalize it, you get some weird error. Okay, so just capitalize it or avoid a lot of problems. And if I've typed that correctly, we'll create a migrations folder for us with our migrations in it. Looks good. So in here, you can see we've got two methods, an up method and a down method. The up method is just for creating the table in the database. The down method is just for rolling it back if we no longer need it. And then to actually apply those migrations, it's just .NET EF database update, and this will actually create our database file for us, assuming everything works correctly. Looks good. So you can see here, here's our no CQRS DB. Fantastic, so that's our data layer all set up. All we need to do now is just do our two endpoints. So we'll move into our program class to do our endpoints. I'm going to kill this. Now, one thing I don't think I mentioned, and I'll just come back to our architecture again, just to be super clear, we've got our two endpoints we're going to build. Now, as we move through the project, these two endpoints, or the contract that these endpoints expose, or what clients will use in terms of calling those APIs, will not change. Okay, so I want to make that really clear. Our internal architecture of our API will change to using CQRS, but what the client uses, exactly the same. And as a client, I basically don't care whether CQRS is being used or not. So that's a really important point that I just wanted to labour. The other thing, which we'll come on to and we'll cover, is that we are returning back order models directly. So what that means is the internal representation of our data in our system or order model is being passed back to the user. Now, you typically would not ever do that. You would have a data transfer object within your API that represents the order, so you're kind of passing a view, if you like, to your consumers. Now, again, that has nothing to do with CQRS. You would absolutely put that in a minimal API, or any API for that matter, using a DTO type structure. Now we are going to implement that as we move into CQRS, but I want to be very clear that while we're doing that as we implement CQRS, it's absolutely something that you can do. It's nothing to do with CQRS really, it's absolutely something you can do in a normal API that doesn't use the CQRS pattern. Okay, so I want to make that clear. And the reason I didn't do it here, although I've kind of, the reason I didn't do it is to save time, but taking the time to explain it, I probably should have just done it, right? Anyway, wanted to call that out. So let's go on and start building our endpoints. So first one's post one, so app map post, and provide the root, so /API/orders. It's an async method, and into that we're going to pass our app DB context. Via dependency injection, we'll call that context. And we'll also pass in an order. We'll call that order. Now again, this is where you would use a DTO. Again, we're not doing that, so tough. Cool. Now again, super simple. We're just going to take that order, put it into our database, and return that it's created. You will get some out-the-box basic validation, but we're not going to do anything explicit here. We will do that as we move through the rest of the project. But you absolutely could do it here if you wanted to. So we'll await on our context. On orders, we're going to add async the order. Cool. And then we'll save it down to the database using save changes async. Okay, so if you don't do this next step, save changes async, even though you've called the add method, until you save, it won't actually get added. And then finally, we're going to return results of created. Okay, so that should be a HTTP 201 as per standard REST conventions. And we want to pass back the route to the resource that's been newly created. So the way we're going to do that is use string interpolation, provide the route, so API orders, and we want to provide the ID. And the way we do that is just by accessing the ID that was created when it was injected into the database. And we also want to pass back, we also want to pass back the full order. What's wrong with this? I think it's a capital I, isn't it? Yeah. There we go. Not the last name, the ID. There we go. And yeah, as I was saying, we want to pass back the full order object as well. So just to recap, created will pass back a 201. We'll get this in the header, route to the resource that's created, and then we also get the full order payload. Cool. And then the last endpoint for now is our get endpoint. So map get. And the route's going to be /API /orders /placeholder for the ID. Again, it's an async method where we will expect an app DB context called context. And this time we'll expect an integer ID to represent the ID of the resource. Cool. So we do want to do a quick check to see whether that resource is there. So the way we do that is by creating a variable called order. And we'll make that equal to waiting on our context to do a find. So orders, first to default async, pass in a lambda, so say O goes to O, it's ID. Equivalent to the ID that was passed in. We'll find an order, that's cool. So we'll check to see whether it's null. So if order equals null, then obviously didn't find it. So we'll just return at that point results of not found. The 404 error. Otherwise, it means we've got something, so that's cool. So we'll pass back return results. Now we're just doing OK. And pass in the order. There we go. Like that. Okay, so very, very simple stuff. Let's run that. .NET run. And we'll test in Bruno. So again, I did want to go through, although I've gone through it very quickly, and it's a very basic example of a minimal API, I did want to start with this. So no CQRS, and then we, value proposition of this video is we then take it and we evolve it. So we're moving on to more interesting stuff next. Right, so let's repurpose this one. Let's rename it. Call it get order. Cool. We will change the route. So we'll say API /orders/1. Call that. We won't have anything. We'll get a 404. So assuming everything else is correct, that's working correctly. Let's clone this. Call it create order. Do we need to change it to a post request? We'll save it and take out the route to the individual resource, and then we just need to pass in a body, JSON. And we'll just quickly do that. So first name. Can't think of any other name. We don't obviously need to pass in an ID because that gets created for us, so we don't need to provide that. Last name. Again, can't think of any other name right now, so that's fine. Status. We'll say paid. Created at. Again, you wouldn't actually pass in the created at date in the API, I don't think. You would do it automatically. And we'll fix that up a bit later, but for now it's fine. And then a total cost, wasn't it? Yeah. It's a decimal, so we'll say it's £100 and 0 pence, or $100 and 0 pence, or 100, whatever you are using, wherever you are. And we'll run that. Cool, so that worked. We got an ID of 1, looking good. Let's just do another one. So we'll just say Sam Johnson. I cannot think right now. Yeah, doesn't matter. Cool, so that's all working. And then if we come back to our getting orders, this should work now. 404 not found. What did I do wrong? API orders 1. Let's have a look at our routes. Make sure we didn't call it order or something. Yeah, there's a mistake. Anybody who spotted that, gold star. Misspelt the route, so let's try that again. .NET run. And try it again. Connection refused. Probably not started yet. Is it started yet? So there we go. Bit trigger happy. And go again. There we go. It worked. And just to test that the not found functionality works, let's just pass in one that doesn't exist, so not found. Okay, so that's all good. Excellent. So that's our minimal API set up. In the next section, we're going to get started implementing CQRS. So before we start coding, let's just take a look at how our architecture is going to evolve in this next step. So this is what we're going to do now. Anything in green is totally new, okay, and anything in the kind of yellowy colour is something that we're going to update or change ever so slightly, or maybe quite a bit. So you can see our model, data DB contexts, all that stuff is not changing, and even the DI container remains the same. What we're going to do as our first step is introduce this concept of a handler, okay, and we're going to have a get order by ID query handler, and we're going to have a create order by command handler. And what these are effectively responsible for doing is working with queries and commands. Okay, so we're starting to go down this route of sort of separating concerns in a more clear way, but also separating concerns, and by that I mean the HTTP endpoints are really going to evolve into only being responsible for HTTP concerns, and any processing is going to be done by these handlers, okay? And we've got a very simple use case today, but imagine something like creating an order where there might be really quite complex logic when you're creating an order, okay? And you wouldn't want to do that inside your HTTP endpoint. You'd want to back it off to a handler. So this is us starting to evolve our CQRS pattern. And technically speaking, I would say that even by the end of this section, we've kind of implemented CQRS to some extent. Now, what we've not done in this, what we won't do in this build is create any services or anything like that. We'll do that in the next part. So that means that the classes, the handler classes that we build are going to have static methods in them that we just call directly without having to instantiate a class or anything like that, okay? So just keeping it super simple and focused on, basically CQRS. So that is what we are going to do. Let's get started. So we're back over in our app. If you're app is running, then stop it, as I've done here. I'm going to get rid of the command prompt. And the first thing we're going to do is create our queries and our commands. So I'm going to create a new folder. I'm going to name it queries. And into that, I'm going to add a new file. And it's going to be get, try that one more time, new file, it's going to be get order by ID query. .cs, and it is super simple. It is just a record called get order by ID query, and it's just an int, and we'll call it order ID. Now these things, queries, can obviously become a lot more complex. Ours is super simple, almost to the point where, yeah, you're going, why would you even bother doing this? And that is actually a really good point. And I think I've mentioned it before, and if I've not, I'll mention it now. CQRS is only worth doing if you've got a really complex problem domain, okay? You would not implement CQRS, as we're basically going to be doing today, with a really simple problem domain. You just keep the API as it was, okay? You wouldn't do it for such a simple application. You'd only really do it if it was worth doing, okay? So technically this is CQRS, but you're probably going to go, well, I would never do it. Like, I'd never implement CQRS if it was that simple. And do you know what? You'd be absolutely right. Okay. So anyway, let's keep going. So super simple query. We're going to create a command now. So new folder, and no surprise what that's going to be called, commands. And into that, we're going to create a new file, and we're going to call it create order command.cs. And the other thing you can sort of see here is, you know, that your commands and your queries are kind of, they're trying to relay your intent of what it is you're trying to do. Now again, these are super simple, so it's like, yeah, so obvious, but imagine commands and queries that are more nuanced. That's where it really starts to become more powerful, because you can straight away look at the command and go, ah, I know exactly what that's trying to do, even if it's a quite complex piece of logic. Okay. 2 is a record. Called create order command, and we're going to expect a string first name, string of last name, string of status, and a decimal of total amount. Total cost, I think we can't call them. Yeah. Now you'll notice that there are 2 things missing there from our model. We don't have an ID, because that's going to get generated for us, and we're not expecting a date time, okay, because we're going to basically create that ourselves. So that is how simple, in this instance, our queries and commands are, okay, and where the real interesting part comes in is our handlers, and then how we use our handlers from within our HTTP concerns. So I'm just going to minimize these, gives a bit more space, and I'm going to create another folder called handlers. And I'm going to create our 2 handlers. So new file, and the first one is going to be get order by ID query handler.cs. Now, depending on your take on it, you might want to put this in with your queries. You may want to do that. Depends how you organize it. I like to keep the handlers separate because I feel they are different to the actual queries themselves. And while we're at it, we'll just create another file for the create order handler, and that is create order command handler.cs. Great. So let's do our get order by ID first. So it's a public class called get order by ID query handler. Got to love these really long names. And then we'll just do public static, so we can call this method without having to create a class, just call it directly, just to keep it really simple. asynchronous, I'm going to pass back task of return type order, which could be null obviously. We'll call it handle. Into that we expect get order by ID query, we'll call that query, and we'll also expect an app DB context called context. And then we return and await on our context. Orders, first to default async. Oh, you've seen this before actually, it's just the logic from within the endpoint. ID equals query ID, or order ID, more correctly. And that needs to be equivalence, not just an equal sign, not assignment. Cool. So basically, as we've said, we are taking the interactions with the DB context out directly out of our endpoint and putting it into a handler. Now again, at this point, you're probably going to go, that's just abstraction for abstraction's sake. It's so simple, I would just leave it in the endpoint. Again, you're right. I wouldn't build an application like this if it was that simple. Again, I've said that before. I'm labouring the point, okay, but I'm just trying to teach you the pattern of CQRS. All right, cool. So that's our handler done. Let's do another handler, the command handler. Again, it's public class called create order command handler. Again, public static async method, returns a task type order. This time it's not nullable because we would, well, expect an order to get created. Call it handle, and into this we expect a create order command. We'll call that command. You'll start to see a pattern emerge here in an AppDB context called context. What we actually want to do is we want to create a new order. So we'll say var order equals new order. And we'll start to assign what we want. So first name on our order is going to be equal to our command first name. Last name is going to be equal to command last name. Status is going to be equal to command status. Created at is going to be equal to date, time, now. And finally, our total amount, total cost equals command total cost. And then a very simple logic that we've already seen before with our context. So we're going to wait on context, orders, add async, add the order. I'll wait on context again. Not even close. Save changes async. And then finally we will return the order. Now one thing you'll note here about both our handlers, I'll save that off, is that they are not doing anything HTTP related. Okay, now I have seen handlers actually return back HTTP status codes. You can do that, but again, the point for me, if you're going to go down this path of implementing CQRS is the separation of concerns. And I feel if you're passing back HTTP result codes in your handlers, then that's just totally blurring the lines of the concerns. So for me, it's quite important that they are very responsible for doing their own thing, okay? And for me, the endpoints should just be doing the HTTP stuff by and large. Now again, this command, super simple. I keep repeating myself, I wouldn't build this if this is all it was doing, but imagine if you were creating an order and before you created the order you wanted to check to see if there was an inventory position on the order itself, or you needed to do some other checks or things like that. speak to other systems, all that kind of stuff, then this is where the power starts to emerge a bit more. Alright, so we've got those queries done, we've got the handlers done. So if we come back to our drawing, just to refresh, we've implemented the stuff in green. All we need to do now is just update our endpoints and we're good to go. So let me just move this back off to the side. We'll do that right now. So the first one we're going to tackle is our get endpoint, this one here. Okay, line 18 onward. Now, again, the signature is not going to change. It's going to remain exactly the same. And in fact, in this instance, we're going to continue to expect just to have an ID passed in. Because the get method, we can't accept complex objects, so we're just going to accept an integer as we've done previously. So it's going to look very, very, very similar. Now here, this is the line we were actually using the DB context and doing all that kind of stuff. Instead of doing this, in fact, I'll just comment it out, we're going to make use of our handler method, okay, and expect to be working with an order object. Okay, so it's basically just a new line in here. So a new line is var order equals await get order by ID query handler. We'll call the handle method. Again, it's static, so we don't need to have an instantiated instance of a class. And then we do have to kind of create a get order by ID query on the fly. So we'll say new get order by ID query. We'll pass in the ID that was supplied to us via the route, and then context, which is our DB context. Okay. And that will do the same thing, okay? That will do the same thing as our original line, okay? But we are backing off to a handler. Next, we'll do our orders endpoint, our create orders endpoint. So rather than expecting an order, we're going to expect a create order command, and we'll call that command. So this is probably a better example of where we're not taking an order, we're taking a command. And as you saw, the command is shielding the consumer from the ID. You need to supply an ID and you need to supply a created that date. Okay, so I'll leave these lines in just so you can see the difference. Just comment them out. But we're going to do something a little bit different. We're going to use a handler to pass us back a created order. So we'll say var created order equals await create order command handle, and we just pass in command and the context like that. We'll then do a quick check here. Too many bits of IntelliSense popping up. So and say if our created order equals null, then we'll just return bad request. Something like that doesn't really matter. Otherwise, we'll do exactly the same thing as before. The only thing we're going to be using here is rather than order, because we don't have orders, we will use created order. Pass that back. Fantastic. Save that off. So that should be us. So let's bring up a command prompt. Let's do a .NET build. Looks good. And .NET run, not rub, and we'll use Bruno to test it out. Pull Bruno back onto the screen. So let's just call our get order. So again, this contract is exactly the same. Let's put in an ID that we know is there. Do it, we get one. It was a bit slow, I think, because it's the first time it's run up. Let's try number 2. Super quick that time, and then number 6 again, we won't have anything there. Cool. And let's create our order, so let's change this to and Chan. Okay, and more expensive order this time, 300 units of currency, and we'll run that, and it gets created. So we have basically implemented very simple CQRS pattern with handlers and queries and commands. and our contract has remained the same. And I'm lying a little bit because we're actually passing over this created data date. Let's take that out. In fact, try that again. We'll do Dave Smith. Again, it didn't really matter because we're assigning the generated date in the code, but I just want to show you that, you know, we are actually not needing to use that, and you get the result back. So again, the contract, apart from that, has not changed, and going forward it's absolutely not going to change, okay? And again, it shouldn't do, because as a consumer, shouldn't care that we're implementing CQRS. Alright, so what we're going to do next is take what we've just done and tweak it slightly to make it a little bit, use better practices basically. What do I mean by that? Well, let's take a look. So this is what we've just built, and this is a very simple CQRS pattern now, but in order to evolve it, what I want to do is this. So I'm going to use DTOs rather than passing back the order entity, or the order model. We're going to pass back DTOs, so we're separating our external contract from our internal data structures. And then rather than using static handle methods, we're going to actually have instantiated classes and do it that way. And we're going to use interfaces, so we have a nice standard approach to implementing handlers that are command driven and handlers that are query driven. Or to put it another way, query handlers and command handlers. And so you can see there in our DI container, we're going to introduce this concept of an I command handler, which is a generic interface. Likewise with a query handler, iQuery handler, and our existing handler classes are going to implement those interfaces in a concrete fashion. And as such, we will then need to update our endpoints to account for that. Okay, so not really anything specifically CQRS, but we're putting your app into a form that I feel is better if you're going to evolve it and scale it out. Hopefully you agree. Alright, so back over in our codes. If you've not done so already, stop it from running. I'm going to get rid of that, and the first thing we're going to do is our DTO. So over in the root of our project, right click, new folder, and we'll call this DTOs. And we're going to create a new file, and we're going to call that order dto.cs. And it's going to be a record, so records really lend themselves to DTOs as they're immutable. And a lot of other reasons as well, but they're a good choice, so that's why we're going to opt for a record. So public record, order DTO, and take a new line. Notice the round brackets, not curly brackets, and then we're just going to define it. So first thing is going to be an integer ID. Next one is going to be a string of first name. Next is a string of last name. String of status. A date, time of created at, and a decimal of total cost. Fantastic. Now, you'll probably go, wait a minute, hang on, Les, if we just bring up our model, exactly the same. Aside from the fact this is a class, the data elements are exactly the same. So what's the point of doing this? Well, the point is, number one, that you are separating out external from internal. So you could arguably change your order entity to something else, holding maybe the same data but maybe in a different way, and you can maintain your external contract by not changing the DTO. The other thing which I find probably is more relevant is that, say you wanted to model some other data point in your entity, such as wholesale costs, so what it costs the organisation to service that order. So consumer-based total cost is $100 for, you know, whatever widget, but it costs us $5. Okay, now you wouldn't maybe want to leak that wholesale cost out externally. It's private, right? So by all means model it in your entity, but do not model it in your DTO. Keep that separation of concerns. I think I've laboured DTOs enough. Let's leave it, but again, I do like the idea of DTOs, and they're very important. You should always implement them, irrespective of CQRS. Right, so next thing I want to do is update our handlers to move away from static methods. So into our handlers folder, new file, we're going to create an iQuery handler interface. So iQueryHandler.cs. And we'll create the other file as well, which is the command handler interface. So command handler.cs. Okay. So we'll start with the query handler. So it's just the public interface called query handler, and this expects a generic type of a T query and a generic type of a T result. So at this point, we're defining our interface. We don't really know what type of query we're going to get, because we could be defining lots of queries in an app, and we don't know what type of result we're going to get. We could have many DTOs in our app, so we don't know that yet. So these are just generic placeholders, as you like, if you like. So what is the actual method signature? So it's going to be a task that's going to pass back a T result. Say it could be nullable, and we're going to call that method handle async, and it expects a T query called query. Okay, so again, just an interface, no implementation. Any class that implements this interface has to implement that method signature, basically. Okay, not got to that yet, but we will. And then we'll do exactly the same thing for command handler, public interface, and handler, and it expects a T command, and we'll pass back a T result. And we want to say where T command is not null. Seems reasonable to me. And the method signature that this interface, or one of the only method signature this interface implements, is also a task passing back a T result. We'll also call it handle async. And we expect a T command. Call command. Alright, okay, so our generic interfaces are done. We now implement these interfaces in our existing handler classes. So let's do a query first. So here's our existing handler class with a static method. So what we'll say up here in the class definition is we'll say it implements query handler. And this is where we specify the concrete types that we are going to be using. So the first thing is the query, so it's going to be the get order by ID query, and we're going to be passing back an order DTO. Now this is erroring because we're not implemented. Again, I've said, if you're implementing this interface, you've got to have the associated methods implemented as well. So let's do that. So control period, implement the interface, and we get a placeholder interface implementation. Fantastic. Now I'm just going to copy this. I'm going to comment it out, and I'm going to cut it, just so you can see what we've done previously. I'm just going to put it down here, okay, out the way. Okay, because we're basically going to be doing the same functionality in a roundabout kind of way inside here. But before we do that, what we need to do is get hold of an instance of our DB context. So the way we're going to do that is constructor dependency injection, so CTUR to define our constructor, and into this we're going to expect an app DB context called context. And then the very standard pattern, we're going to define a private read-only type called context, and make that equal, not that, equal to context. This is erroring out because this is underscore context is obviously not defined anywhere, so cursor in there, control period, and we're going to generate a read-only field called context. That is definitely a mouthful. And then inside our actual new implementation, what we're going to do is we're going to create a variable called order. I'll make that equal to just this existing functionality. Copy that, paste that there. This will error because we're using underscore context now, and this is erroring out. Let's see why. Because we're not using yet the async modifier, so we have to put that there. This is erroring out because not actually returning anything yet, so that's okay. So we want to do a quick check. We'll say if the order null, then we'll just return null. Otherwise, we're going to create a new DTO or return a new DTO. So we're going to return a new order DTO, round bracket. Why it suggested that. New line, we'll put the semicolon in, and then we'll just populate the items. So first thing is going to be the order ID. Next thing is going to be the order first name. Next thing is going to be the order last name. Need to put commas at the end of this. And this is exactly the type of use case for AI assisted coding that is brilliant. I'm not doing that here, but I normally would have an AI assistant helping with this stuff, and it'll just do tab completion basically. Really, really good. So I'm a big fan of that. And then, but instead you have to watch me type it, so which I'm sure you're all really loving. And then order total amount. Total cost, not total amount. Okay, cool. So that should be good. So we'll save that off. Looking pretty good. I'm going to get rid of this. It was just to show you that we're basically essentially doing the same thing. Right, so save that again, and then all we need to do is similar thing in our create order command handler. We're going to implement the interface. So up here, we're defining a class. We're going to say it's going to implement the iCommand handler. And what command are we expecting? We're expecting the create order command, and we're going to pass back an order TO. Perfect. Likewise, we're getting an error because it's not implemented, so control period, implement the interface. I'm going to put in the async keyword here, and we'll, yep, that's looking pretty good, and we'll start to implement our interface. Actually, before we do that, let's comment this out, like we did before, similar thing. Use constructor dependency injection to get our DB context. So let's pop that down there. Up here, we'll do a constructor, CTOR, tab, app DB context called context. In here, we'll do a private read-only field called context. Don't know why it does that, it's really weird. SQLite, no idea why it wants to do that. And then again, control period, we will do, it's not giving me the same fix as I'd expect before, so it's okay. We'll just do let's do it ourselves. Private, read only, app db context called underscore context. Fantastic. And in fact, what we're going to do, I'm going to uncomment this. We're going to basically reuse exactly the same code here, these lines here, exactly the same things before. Just cut it out just so you can see what's being used. Paste it in there. So we're going to create a new order based on the command attributes. We'll need to update this to use the underscores, like so. And then rather than returning the order, we're just going to return the DTO. So I think we can get rid of that now. We don't need that now. And we'll just return a new order DTO, round brackets, put semicolon at the end, and I might cheat and come over to our, just copy this out. I'm sure you don't want to see me typing that again. It should be exactly the same. Looking pretty good. Okay, so the only errors we've got now are over in our program class where our endpoints are. These are obviously not correct anymore, so we've got to do a little bit over here to use dependency injection. So we do want to register our interfaces and our classes in our DI container. So user builder, services, I'm going to add scoped. I'm going to pass in the I command handler, and we're going to tell it. Again, we need to tell it what type of command we're expecting in this instance, and the fact it's an order DTO we're passing back. Cool. And we're saying you're going to use the create order command handler for that. Fantastic. And then likewise, we're going to do the same for our query. Services, add scoped, let's see, query handler, what we're going to expect, get order by ID query, and we're going to pass back an order DTO, and then we're going to use the get order by ID query handler, like so. Fantastic. So they're registered in our DI container now. So we'll do our read operation first. So the signature the path remains exactly the same as before. We're still going to expect an integer passed in. We're not passing the DB context here though, okay? We don't need to do that here. Instead, what we're going to do is we're going to say an I query handler of type get order by query and an order DTO. And we're going to call that handler. Okay, so that's basically creating our handler, alright. And so I'm going to comment this line out because it becomes a little bit simpler. Instead we just say var order equals await handler handle async, and we just pass in a new get order by ID query with the ID passed in. Alright, so similar but different. Okay, similar but different. And then up here, I'm going to do pretty much the same thing. Still going to expect the create order command. We're not going to pass in a context anymore. Instead, what we're going to pass in is an I command handler of type create order command order DTO, and we're going to call that handler. And we can get that and just say await order handler handle async. We just pass over the command like so. Right, so quite a lot of coding actually for some relatively simplish changes. So let's test it out. Let's get the terminal back up and running. Let's do a .NET run. Hopefully no build errors. And again, labelling the point, there should be absolutely no changes from our consumer perspective. Should be exactly the same as before. We've just changed some internals around. So let's get Bruno back up and running. Let's get an order. So find one that should be there. Great, let's do 2. Fantastic, and then let's create an order. Let's say Emily Davis or something like that. Alright, and that works as well. Okay, so you can see from a consumer perspective, creating an order, getting an order exactly the same, but we've re-architected the internals of our application to be something a little more enterprise grade, but arguably more complex as well. Okay, it depends upon your perspective. Sometimes I find writing code like this is more complicated than the way we had it, and it's certainly a lot more complicated than the API we had to start with. Let's park that thought for now, and we'll keep going with CQRS, but we'll revisit that concept of is this worth it, but we're not there yet. So take a quick pause there, and the next section what we're going to do is look at validation. So yes, we want to now move on and add validation into our app. So let's take a look at the architecture and see how it's going to evolve. So what you can see here is what we've just done. What we're moving on to do is this here. And you can see there's only a few changes and additions. Specifically, we're going to be working with the Fluent validation framework, okay, to enable validation in our app. And as part of that, we're going to create a validator class called create order command validator. And no surprises, we're going to inject that into our existing command handler. And we have this iValidator interface as well that we get with Fluent validation. Now, you'll see how all that is implemented when we come on to doing the code. I do just want to call out though, and I'm sure you're probably already aware that validation isn't unique to CQRS applications. Okay, if you've done any API stuff, you'll have, I'm sure, written validations for them as well. Okay, and so I want to call that out. It's not unique to CQRS, and if you've done anything in the .NET space, you might have implemented validation in your endpoints. You might have done it in the middleware. You might even have used filters. Okay, so there's a few places where you can put validation. Some of those ones I've just mentioned are really suited to more cross-cutting concerns where you need to validate across the entire app. What we're really talking about today is validating our commands, because remember, what commands are really doing is changing system state. That's the intention of them. They intend to change system state. So as part of that, you want to make sure that what they're going to do is correct or valid. And so that's why we're working in this way today with this pattern. But validation generally is a general concept. Alright, cool, so let's move on and start coding. So I'll move that off to the side. I've got my CS proj file open and I want to add .NET add package fluent validation. We'll add that in. Fantastic. Then in our commands folder, we've got an existing command. We want to validate this command in effect. So into our commands folder, we'll add a validator. So new file, and we'll call it create order command validator.cs. Make sure I spell it correctly. And it's just a public class called create order command validator. And it then implements this abstract validator of type create order command. And what this is in effect saying is that this validator is tied somewhat to this command and it's validating its correctness, basically. Okay, fairly straightforward. So we will create a constructor, no parameters, take those out. And inside here we just create these rules. Okay, so you say rule for using this lambda expression, so we'll say x goes to x first name, and again it's picking up the properties from our create order command, and then you can add all sorts of validations. Okay, we're just going to keep it super simple and say not empty, and we'll just do it the same for all of our string based properties. So rule for, we'll say x goes to x, last name not empty. In fact, I'm going to copy this. Oh. And I'll just change this out for status. Cool. And then the last one is going to be for total amount or total cost. Total costs. But what I'm going to say is not empty. Take caps lock off. This would be helpful. We're not going to use the not empty method. We're going to say greater than 0. Cool. And again, with fluent validations, all sorts of stuff you can do. This is exceedingly basic, as you can see. For something like an order, you could go quite crazy with validations and start looking at business logic and all that stuff. But this is fine for just now. So save that off. What we then want to do is go into our program class. We want to register that in our DI container. Let me just get rid of the command prompt so you can have a bit more space. Now we do that by accessing a builder, accessing services, adding a scoped registration, and this time we're going to add iValidator. I'll type create order command, and then we're going to wire that into the create order command validator like that. And put the angled bracket here, I believe. There we go. Fantastic. And then what we need to do is we need to inject that into our command handler. So down in handlers, create order command handler. In our constructor, we're going to create another private read-only field called underscore validator. And we'll make that equal to validator. And we should probably also put it up here. That would be useful, wouldn't it? So what type is it? It's iValidator. I'll type create order command. I'll call that validator. Minimize that, and then we just do the control period to generate a read-only field, like so. And then we want to validate our command, so we want to generate a validation result, so we'll create a variable called validation result and make that equal to wait underscore validator validate async and we want to validate the command. Okay, I think that's fairly self-explanatory. I want to check if it's not valid. So we'll say if not, validation result is valid. So something wrong, then we'll throw a new validation exception with our errors, validation result, errors. So I think that's confusing things. Let's take that out, and we don't need this. And it's not equals, it's errors. A couple of things wrong with that. That's better. And then the rest of it's just the same. Okay, we're just doing exactly the same thing because it's valid from this point on. And then just coming back over to our program class, we want to catch that exception if something happens. Okay, if it's not valid, then we want to obviously catch that out. So we'll put a try catch block here. Say try. If that's all cool, we just do this exact same stuff here. Don't change that. Otherwise, we will catch our validation exception. Draw EX. And I'll create a variable of errors. Make that equal to our exception. Errors collection. We'll just select what we want using a lambda. So E goes to new E property name. Error message, close that off with a semicolon, and then we'll just return results add request with our errors, like so. Fantastic. So I think that should be everything. Okay, so let's just check our architecture. Pull that back onto the screen. I think I captured everything there, didn't I? So we created a validator class. We've registered it in dependency injection. We're injecting it into a handler. Actually, this one here should probably be yellow because we are changing that, aren't we, as well? So we'll update that. That's cool. And we've done that in here. So that should be okay. So let's run it up. .NET run. And we'll try and create a order, but we'll create a successful order just to make sure we're not broken anything. Let's bring Bruno back onto the screen. Let's just use this same one again. It's fine, isn't it? So that's all good. And then let's just not put a first name in. We'll pass an empty string. See what we get. There we go. Property first name must not be empty. If we take out the last name of David, we'll try that. Great. You can see we're getting an array of errors, which is really quite cool. Put a total cost of 0, and we get that as well. Okay, so that is validation added into our CQRS app, into our command. Okay, and again, you could go crazy with this stuff, but keep it relatively simple and leave it there for now. In the next section, we're going to add another query handler into the mix, and just to embed the pattern before moving on to some more interesting stuff around emitting events and doing all sorts of other things that arguably a lot more interesting, but we'll come on and do that next. So moving on to our next section, this is what we've just done, added validation. We're going to now do this, and what we're really doing here is just embedding the pattern that we've already seen before. And you might go, why are we doing this? Isn't just repeating ourselves? Well, absolutely, it's exactly what we're doing. We're just repeating ourselves. And the reason I want to put this section in is just so that you can understand when you have multiple queries or multiple commands, what would that look like in your application. And so you have a separate handler, certainly the way I'm doing it, you have a separate handler, separate query, and in our case, a separate DTO, a separate endpoint. Okay, so it's just to allow you to compare what that would look like, okay, if you're adding more stuff into your app. And if you've done any general API tutorials, this will look familiar to you. You always have a endpoint that creates a resource, gets an individual resource based on its ID, returns a list of resources, which is what we're doing here, and updating and deleting, which we're not doing today because it would just drag it out a bit too long, and maybe that would be a good step for you to do, is to implement delete and update as commands in this application. But this is what we're going to do next, return a list of orders, okay? And It's going to embed the concepts we've already seen and also labour the fact that you can return data back in a slightly different way, a slightly different looking way. Even though it's based on the same model, using DTOs you can present it back slightly differently. That's it. So it's a pretty straightforward one, and yeah, it's just really to embed what we're doing. Before we move on to the more interesting stuff of events and eventual consistency and all that cool, arguably more complex stuff. So let's start coding. So back in our project, we're going to create our DTO first. So right click, new file, and then call it order summary DTO CS, and control number 2, just to bring up our existing DTO, and you can see how this one is going to differ slightly. But it too is a public record. I'm going to call it order summary DTO. Round brackets, put the semicolon in. And then we're going to say the first attribute, or the first property is called order ID this time. Okay, so we'll move away from that convention of just saying ID. We'll say order ID this time. So same data, different information, though, different presentation. We'll have a string of customer name. Okay, and what that's going to be is a concatenation of the first name and last name. Okay, now I actually hate that. I hate when names are structured in that way, but again, for demonstration purposes, we're going to create a customer name. So next one is going to be string, and it's just going to be status. We're not going to change that, so exactly the same. And then the last one we'll do is decimal of total cost. Again, totally the same. So again, the idea is this is just a summary. We're not going to include the created that date, and we're providing the customer name as one kind of unit. Alright, that's it. So we'll save that off. You can get rid of this now. Not get rid of it, just clear it down. You don't need to see it. Next thing we'll do is create our query, and that's even simpler. Okay, and I've just realised that my queries folder has got a space in front of it. So let me just rename that. Doesn't make any difference to our code, but it was just annoying me. So, okay, queries is in the right place now. And in here, we're going to create a new folder, a new file, new file called get order summaries query.cs. Fantastic, and this is mega simple. It's public record called get order summaries query. That's it. Because we're going to be super simple this time and just go give us everything, whatever it is, or not, might not have anything. You could obviously evolve this and make it more complex and have filters like give me every order that's been created since this time and it has this status, but again, I don't want to go there. Again, it would be another thing that you could look at doing to extend this example. Point of what I'm doing here is just to embed the pattern. Alright, so keeping it simple, that is a query. And then, not lastly, but next we need to do a new handler. And again, the way I'm doing it, you would have a handler for every query, you would have a handler for every command. So right click handlers, new file, and we're going to call this get order summaries query handler. And I do apologise if you can hear birds squawking away in the background. Nothing I can do about that, unfortunately. They're very noisy though. So this is just a public class called get order summaries query handler. Got to love these massive long names. They get a bit unwieldy, to be honest with you, so you've got to be really careful that you don't make any mistakes. Anyway, implements our query handler interface of what query type. It's a get order summaries query, and it's returning back a list of order summary DTOs. Fantastic. Now this will be complaining because we've not implemented the interface that we expect. So again, just coming back to our query handler, just to remind you, we need to implement this handle async method here, which we've not done yet. Again, we could do control period and implement the interface. Why don't we just do that? Saves a little bit of typing. And yeah, that's fine, we'll come on to that in a minute. First of all, we have to do our constructor because we need to get hold of a DB context. So into here, we're going to expect an app DB context. That's injected in, and we'll assign that to a private read-only field called underscore context. Excuse me. And context. Okay. And what we should be able to do is control periods. Yeah, it's not doing that. We need a public read-only field. Public read-only at DB context. Underscore context. Perfect. Okay, we'll come down here. Now this needs to be async. Put that in. This is going to complain because we're not using the await keyword. That's okay. We're going to do that now. And we're just going to return await our context using our orders. Use a select statement, allowing us to select what we want, what fields we want, columns we want, whatever you want to say. So we'll say O goes to new order summary DTO. New line, and in here we'll just say we want O ID, we want O first name plus, this is where we're building up our customer full name. Put a plus sign in there. Okay, so we're just putting a space in. Actually, my JavaScript is leaking in there, double quotes, not single quotes, and then new line, just the status, which is fairly straightforward, and finally just the total cost, which is also pretty straightforward. And we'll say to list async. Okay, and that should be that. Alright, so hopefully that makes sense. Very, very simple. It's not really doing much other than saying just give us whatever you have by way of orders, and we're kind of constructing our DTO. Alright. All that remains to do now is then just create our endpoint. So over in program, up here we want to register our new handler. So referencing builder, referencing services, and add scoped, add query handler, get order summaries query, returning a list of order summary DTO, and we're mapping that to the get order summaries query handler, like that. Close that off. Okay, so that's registering it for use, and then we can do our endpoint. We'll do it down here. App map get, just get request. Double quotes, create a route, so it's API / orders, and it's async. Into that we expect an I query handler, and get, expecting a query called get order summaries query, and passing back a list of order summary DTOs. Like that. And we'll call that handler. That goes to this, put in the semicolon here. So we'll create a list of summaries, and that equal to await, on our handler, handle async, new order summaries query. Now we'll just return results. Okay, and we'll just put the summaries in there. If there are any, could of course be empty. Now again, this is super simple, but you could make this more complex. And again, you want to add things like pagination and all that sort of stuff. So if you had, like, you know, 1 million records returned, you wouldn't want to return 1 million records. With this, you'd want to you'd only want to return 1,000, say, and then page through the result. Again, that's just way out of scope of what we're doing here, but you absolutely should implement that type of thing. Fantastic. So let's do a .NET build just to see if we've got any errors. Don't have any. Great. So let's do a .NET run. And once that's run up, we'll test out in Bruno. So bringing Bruno or whatever tool you're wanting to use back onto the screen. Just make sure it's running this time. And what I might do is just clone this or copy this or whatever it's called in this tool. So I'll just say get order summary. Okay. There we go. And we take out the ID. We don't want to call the old endpoint, and we'll just run that now. And there we get all of our orders. Looking pretty good. And again, you know, just labouring the point, if you had a million orders there, you wouldn't want to bring them all back. You'd want to page through, and you know, usually the way you do that is by defining query string with, you know, the page size and, you know, the cursor and all that kind of stuff. But might be a useful one for you to have a crack at extending this particular query. Okay, cool. So hopefully that's just embedding the pattern. Great. I think we can move on from that now. And what we're going to do next is we're going to start emitting events. So let's get on with that. So yeah, in this section we're going to introduce the concept of events. And if we move over to our architecture, you can see what we'll have at the end of this section. And we'll start by defining a new interface, iEventPublisher. We'll then create a class called the console event publisher that will implement that interface and emit order created events. And of course we'll have to update our create order command handler to trigger those events. Okay, so we'll jump into the code in just a second, but why are we doing this? Why are we emitting events, order created events? Well, in the next section we are going to split our database into two. Okay, so sometimes you'll find in CQRS patterns that people will do that. They'll split the database into two, read and writes. Now, it's not technically part of, it's not strictly necessary to do it if you're implementing CQRS. That's really part of the internal app, but we're going to do it anyway because it's an interesting thing to do. And as part of that, we'll want to ensure that the two data sources remain in sync with each other. And we're going to use events to do that. So that's why I'm doing it. So very relevant, I think, to CQRS. More broadly speaking, I like event-based systems, especially in distributed architectures, microservices architectures. They are very, very important. They're key, in fact. So, for example, let's say this was our e-commerce application. It's emitting order created events. Other systems within our distributed architecture, other services within our architecture may want to know about those events so they can do something with it. So let's say we had a inventory management service that wanted to adjust stock levels for products. It would be interested in order created events because it could then understand how many of a particular product have been purchased and adjust stock levels. There's lots of other use cases, but generally events are an interesting and useful thing to have. And then more specifically, when you look at CQRS, CQRS is often used as a kind of foundational architectural pattern within something called event sourcing. Now, we're not going to get into that today, but as the name would suggest, it's heavily reliant upon events and very high level. Rather than just having one record in a data set related to an order, that you just update that one record, update its status or whatever. With event sourcing, you don't have that. You just have multiple events related to the order, and you look at the entirety of those events to get a picture of what the current state of the order is. Very interesting concept, a bit different from what maybe you're used to doing, and I might cover it in another video. But the point being, heavily reliant on events, and CQRS is often used as part of designing an event sourcing system. Anyway, gone off on a bit of a tangent, kind of. Let's go on and start writing some code. So let's move this off to the side. Back in our project, just make sure it's not running if you had it running, and we'll get started. So the first thing we'll do is create a new folder for our event stuff in the root of our project. So right click, new folder, and call it events. Cool. And the first thing we'll create in here is our interface, so new file, iEvent publisher.cs, and it's just a public interface called iEvent publisher. And we'll just define one method signature, so it returns a task. It's called publish async. returns a generic event type, T event, and it expects a generic event, so T event, and we'll call that EVT. Like so. Save that off. Next thing we'll define is a concrete class, the console publisher, console event publisher, so new file, and we'll call that console event publisher.cs. It's a public class called console event publisher, and it will implement our interface, so our event publisher. Erroring out because we've not implemented that interface, so cursor in the offending article, control the period, implement interface, and very, very simple for the moment. We will change it up though. We'll introduce another concrete class to work with events, but this one's just very simple. It's just a console byte line, and we'll use string interpolation, and we'll just print the event to screen. So we'll say event published, and curly brackets EVT. Okay, and it has to return something, so we'll return task completed task more correctly. Cool. And then we also need to define our event, the event itself that we're going to emit, and it's very similar to DTO really. So right click, new file, order, created event.cs. And if I've not mentioned it already, you'll notice the naming kind of convention for events are past tense. Okay, so order created event. Okay, so it's happened in the past. Okay, so when you're naming events, that's really how you should go about doing that. And it's a public record called order created event. In brackets, and we just define it. So we'll say int order ID, string first name, string last name, and decimal total cost. Now we'll save that off, and just to do control number 2, just to compare it with our DTO, order DTO, you can see it's very similar. But we're not including the status, and we're not including the created at date. We'll leave that for now, and you'll see why in just a minute. Alright, so let's get rid of that. Then let's just look at architecture just to see what we've left to do, so I don't miss anything out. So we've done that, done our interface, done our concrete class, done our event. We just need to use it within our command handler. Now, before we do that though, we do need to wire everything up in here. So let's register it in our DI container. So builder, services, we'll add a singleton, and when we ask for an event publisher, we're going to give it a console event publisher, like that. Okay, cool. And then we can come over to our handler, or our created handler. Create order command handler, and what we're going to do first of all is we're going to inject an instance of our event publisher into the constructor. So in our method signature here, comma, and it'll say event publisher, call it event publisher, fantastic, and then here we'll do underscore event publisher equals event publisher. And we'll see if we can do control periods, generate a read-only field. There we go, fantastic. And it means we can use it. So in our handle async method, just come down to where you are saving the changes to the database. So we've already created an order, it's in our database, safe and sound. We now want to emit an event. So we'll create a new var called order created event. That equals a new, nope, doesn't equal that, it equals a new order created event. Yeah, IntelliSense and autocomplete are good, but sometimes it does random stuff. Well, it appears to me to be random, but maybe it's not. and we'll just define it. So the order ID is that, first name is this, the last name is that, and the total cost is this. Fantastic. And then we just call our event publisher. So we do an await on our event publisher, we publish async, and we're just going to pass into that event order created event, like so. I think that should be everything. So let's do a .NET run. Fantastic. Let's bring Bruno back up and keep your eye on the console down here. That's really what we're interested in today. So let's create a new order, Kenny Rogers. And it usually takes a bit of time because it's just the first time it's run, but the most important thing is, yes, we're getting a new order back, which is cool. You can see that we're actually getting an event published down to our console, which is exactly what we wanted. Superb. So that's all looking pretty good. In the next section, what we're going to do, as I've already mentioned, is we're going to split our databases in two, and then we'll use events to ensure eventual consistency. So we'll do that next. Okay, cool. So splitting databases. So let's take a look at this next section, and this is what we're going to end up with. And you can see what we're doing here. So actually, just coming back here, you can see obviously we've just got one database and one DB context. When we split our databases, which is the whole point of this particular section, we're going to end up with a write DB with a write DB context, and likewise a read DB with a read DB context. And you'll notice that these handlers here, the query handlers, two of them, they will use our read DB context, and our command handler will use our write DB context. And you can see up here in the DI container, we're going to have, two new DB contexts, and we'll kind of retire the original DB context. Our event is still going nowhere at this point in time. Now, for those of you who may be kind of clued into this at this point, at the end of this section, we'll have two databases, and everything will work as before, but the only difference will be when we create a new order, it's going to get created, but it's going to get created in our write database. It's not going to appear yet in our read database. So the querying will still work, but it's just not going to return anything because there's going to be nothing there related to our new orders that have come in. Okay, and we'll solve that problem, of course, in the section that follows. But that's what we're doing now. We'll do it in phases. So let's go on and start splitting our database. So a few things we need to do. Let's come back over here. If your application is running, just kill it. I'll get rid of this for the moment. And we're going to have two new databases. So the first thing I'll probably do is just create two new connection strings in app settings JSON. So just copy this. Actually, I won't bother copying it. It's not going to really give us much. We'll say this is the write DB connection. And actually, we'll copy this. Saves us a little, tiny little bit of typing. And we'll do that. And we'll just call this write DB, and copy this, and we'll have another one, and we'll call it, no surprises, read DB, and the connection string will be read DB. Now, I think I mentioned it already, we are going to split our database into two. We're just using SQLite. We're doing it purely from a theoretical perspective, so we're not doing any database tuning or anything like that. If you were doing this in the real world and you were going to the trouble of implementing CQRS and having separate data sources, then the whole reason for doing that would be to optimize the system. And so you may use completely different database platforms for reading and for writing to what you would do. Or you might use the same platform, but they would be optimized differently. Now, that would be the role of a database administrator or someone in an operations team to tune those databases so they were absolutely maximized for reading and writing. And personally, if you're going to go to the trouble of implementing CQRS, I would be, very keen to also have separate data stores. That does bring, number one, extra complexity, of course, and that's what we're tackling here. And also technically splitting the databases is not technically part of implementing CQRS as well. So you need to be aware of that. It's just something that often happens. And for me personally, I think it makes sense. If you're going to the trouble of doing it, then you want to probably split your databases. But all we are doing is literally having two separate database files in today's video. Okay, all that other stuff is way out of scope. Alright, cool, so we've got our two different connection strings, that's cool, and get rid of that for now, and let's create our two DB contexts. So in our data folder, right click, new file, and we'll call the first one, right, DB context.cs, and we'll create the other one, and it's read DB context.cs. And I'll do a little bit of cheating. You know me, I do like typing code out, but I'm going to do a bit of copying and pasting because you've already seen me type this code out before, so it's not going to add a lot of value if you watch me do it again. And all I'm going to do is just change the name of the class, obviously, to the appropriate name, and don't forget to do it here as well. Okay, so this is our read DB context. Yep, we've done it the right way around, that's cool. And then we'll do it for write as well. So let's paste in, and we'll call this write, and we'll call this write, and we'll also do it for this as well. Now another thing to notice is that we're using the exact same model. We're using the orders model in both cases. Now again, entirely conceivable, because you're going to the trouble of having two different data sources, you may want to structure that differently as well. We're not doing that today, we're just keeping it exactly the same, but you could have different slightly looking structured data, especially if you are using NoSQL databases versus a relational database, all that kind of stuff. But again, that would be too much for today's video. Cool, oh, I've not saved this one, let's save that, let's save this, cool. What we'll then do is we'll come into program and we'll register those in our DI container. So I'm just going to copy this line here, paste it in, and we'll just register a new context. So read, and we'll just get the right connection string. What was it called? Read DB connection. And put that in here, like so. And I'll copy this, and you just need to therefore change a couple of things. So we'll change this to write. Right. Cool. Looking good. Save that off. Oh, that wasn't looking good. That's looking good now. Fantastic. And then I think all we need to do is just update our handlers. So we'll just go through them one by one, starting with our create order command handler. So this is going to use our write handler. So rather than using appdb context, it's going to use write DB context. I'm just going to keep the name the same, just so we don't have to change too much. And then here, change it to that as well. I think that's the only place you need to change it, because everything else is exactly the same. So we'll save that off. We'll find out if it's not everything we need to do when we come to run it. And then our two queries, we need to change that over to the read DB context. Read DB context. And where else do we need to change it here as well? So I think that's looking good, and then same for here, read and read. Perfect. Okay, cool. Now, as you'll remember, when we set up our first database, we had to generate migrations and we had to update our database. So it's no different. We're going to do that here as well. So let's bring our command prompt back up. I'm going to clear the screen to give us a bit of breathing space. And we're going to generate our migrations. So it's .NET EF migrations add, we'll call it read DB migrations. We need to specify the context that we're wanting to work with. So the context is read DB context, and we'll want to put directory, the migrations into a different directory, or the same directory but into a subfolder. So migrations / read. Okay, so it's going to go into the same migrations folder, but we'll just segment them. Okay, so hopefully I've not made any typos. We will find out if I have. Looking pretty good. So we should have our migrations in here now. Yeah, cool. There's a folder called read, and there's our read migrations. Perfect. We won't do our database update yet. We'll do that in the next step. So here we'll just do our our write migrations. I'll change that to write. Use our write DB context. I'll call that write DB migrations. Okay, again, these are identical, obviously. They're even identical to what we've done before, but arguably they could be different. So it's worth just showing you how to work with multiple DB contexts as well if you've not done that before. Looking pretty good. So let's now update our database. So you'll see we don't actually have our databases yet. This will happen now. So .NET EF database update, and we just supply the context. So let's do our, doesn't really matter, does it? Right, DB context first. Why not? And you should see that appear here in our file list. Pretty good. And again, you can see it has appeared there, so that's wonderful. So clear the screen, up key, and we'll do it for our read migrations. Oh, that's all we need to do, isn't it? Okay, cool. Run that, and we'll have our read database. Looking pretty good. Okay, cool. So clear the screen, we'll do a .NET run up our app, and we'll start testing now. Now, one thing we can do straight away, well, obviously of course, is we can use our queries to read our data. So let's get all of our orders. Now, I'm stating the obvious here, I'm sure you know this, our existing orders are in our old database, in our no CQRS DB. So our new read DB has nothing in it. So this will return nothing. Empty. Set, and same with getting an order. Let's try and get order number 1. There's nothing there. You get a 404. So let's try creating an order. Okay, we'll create one for Kenny Rogers again, excuse me. And you'll notice, obviously, when we were using our old database, we'd already had 8 orders created. We should get a new order, but I'd expect the ID to be 1. Indeed it is. Okay, and we should also have an event emitted as well. So everything is working as before. It's all looking pretty good. If we, again, stating the obvious, we come back and query our read database, we still have nothing. And we try and get order 1, we still have nothing. And of course, I've already explained why that is the case. So let's take a little pause here for now, and then the next section, kind of the final section, not quite, but almost, we're going to rectify this issue. We'll do that next. Okay, so yeah, we've just split our databases successfully, and everything is working as you would expect. Of course, as you've just seen, the only thing that is not working is when we create an order, we can't read the order. Okay, it's not propagated its way through to the read part of our application. So we're going to move on and fix that up now. And so this whole concept is referred to colloquially as eventual consistency. So the two data sources will eventually be the same after a time, hopefully very, very quickly in our case. So this is what we're going to implement. We're going to create a new interface called iEventHandler, which we'll come on to in just a second. But before that, we are going to replace our existing console event publisher with a new in-process event publisher. And when we say in-process, I mean it's just going to be done in the app. Okay, we're not going out to an external service bus or anything like that. Okay, so what this publisher is actually going to do, it's going to look at our DI container, and it's going to look for any classes that implement our new iEventHandler interface, and if so, it's going to send events to those. That's basically what that's going to do. So it's all in process. It's going to be pretty quick. Okay, the event doesn't change. The event's exactly the same, and then yes, we're going to have our new event handler, which is implementing our event handler interface. Now you'll notice the name of this class is Order Created Projection Handler. And what is a projection? Well, a projection is a more intricate concept within CQRS. It's tending into the more advanced subject areas. We're going to touch on it here today just so you have a flavour of what it is. And what are they? Well, basically, projections are responsible for taking events, such as our order created event, and creating read models from those events, which is exactly what we're doing here. We're taking events and we're going to put it into our read domain, and therefore we can read things based on events effectively. That's what a projection is in a sort of high level nutshell. Okay, and that's it. Okay, so by the end of this section, we're going to have CQRS implementation that I think is, you know, for a beginning course, plenty. Okay, and I think there's lots you could do with this to evolve it forward. Okay, from here, but I think it's a good grounding to get us started. All right, let's start coding. So let's move this off to the side. Let's minimize Bruno for the moment. And we'll come into our events folder, and the first thing we are going to create is our event handler interface. So right click events, new file, it's event handler.cs, and it's just a public interface called event handler. And just one method signature returning a task called handle async, and it's going to expect generic event type called t-event, and we'll just call that EBT, like so. And it's not what we want, so let's try that again. Event. Oh, I know why that's erroring out. We need to pass the type in here. T-event. There we go. Fantastic. Cool. And so now that we have our event handler, why don't we, our event handler interface, why don't we create our projection handler? So in order to do that, you could put it in our handlers folder, absolutely, but I'm actually going to create a separate folder called projections. So in here, right click, new folder, and we're going to call it projections. And then to projections, right click, new file, and we're going to call this order created projection handler.cs, and it's just a public class called order created projection handler, and it's going to implement an event handler of what type? Order created event, which we've defined in the previous sections. Let's implement this interface, so right click, control period, implement the interface. Fantastic. And so before we actually do that or work with this, we need a constructor in order to get a database context. So ctor, and into that we're going to pass a read db context, we'll call it context. And in here, private read only. Oh, there goes the context. Let's do control period. It's not giving us what we want, so I'll just do it manually, and we'll say private read only read db context called context. Fantastic. Now there's an issue here. Let's see what the issue is. Order created projection handler will be. There you go. Spelt it. And also spelled that wrong as well. Not really getting much right, am I? There we go. It's better. And then in our handle async method, just get rid of this not implemented exception, and we'll just create a new order. ID equals EBT order ID. First name equals EBT first name. Last name equals EBT last name. Status. We will just define our own status here. We'll say created. Created at equals date time now. And the total amount or total cost equals EBT total cost. Semicolon there, and then we'll await on our context. Using orders, we'll add async. we're going to add our order. Pretty basic stuff really. And then we'll save changes. Waiting on our context, save changes async. Like that. Okay, so let's just do a quick check of our architecture. So we pull onto the screen. Here we go. Make that a little bit bigger so you can see. So we've just implemented our interface, our event handler here, and we've just implemented this class, and it's using our DB context. So all we need to do now is just create our in-process event publisher, and then of course we have to wire everything together in program. So next thing we need to do is in events, right click, new file, and we're going to call it in-process event publisher CS. Public class called in-process event publisher, and it implements our event publisher. So and we'll implement interface, so control period, implement our interface. Before we do that though, again we need a constructor, because we're going to make use of something called an I service provider, called service provider. And this is going to allow us, as I've said already, to interrogate our container and look for anything that has, we come back to our order created projection handler, that anything that implements this I event handler interface. We'll look for anything with that, and anything that's registered with that, or anything that's implementing that interface, we can then send events to it. So you could have multiple classes that are doing that, but we just have one. So anyway, back here, that's why we're using the I service provider. Again, standard pattern underscore service provider equals service provider. And let's see if control period works. It is. So let's just do a private read-only I service provider underscore service provider, like that. Cool. And then within our publish async method, let's get rid of this. I'm going to say using new variable called scope. I'll make that equal to underscore service provider create scope, and then we'll use that scope to create a collection of handlers. So if our handlers equals scope, service provider get services, and I make sure you use the pluralized version of this. And what we're looking for, I event handler. Cool, okay. And then what we're going to do for each potential handler that we have, extract the handler. Oh goodness. In handlers, simply going to await that handler, handle async, and we'll pass in the event, EBT, like so. Wonderful. And then all that remains to be done, and actually, sorry, I'm just going to stop this from running, get rid of that. All that remains to be done is to come over here and wire everything up. So back over in program. First thing we want to do is swap out this registration here. So again, before, if you ask for an event publisher, you get the console event publisher. We want to switch that out to the in process event publisher. And that's why I love dependency injection. It's so easy to switch out different classes like that. It's really cool. And then we need a new registration for our handler stuff. So services, we'll add a scoped to I event handler. Order created events goes to order projection handler. Like that. Save that off, and I think that is everything. I think that's everything wired up. Let's just look at an architecture. I think I've done everything that needs to be done. Yeah, okay, we'll find out if I haven't. So let's get our command back up. Let's clear the screen. Let's do a .NET run. Does the build anyway, doesn't it? Looking pretty good. Now, of course, I mean, assuming this works, let's just test it first of all, and I'll say what I was going to say next. Well, actually, let's do what I was going to say. If we, just because we've done that and we run get all our orders, it doesn't mean to say, of course, that the order that we created previously magically appears, because the event's already been and gone, okay? So you're only going to get orders that are now triggered, okay? I'm sure that made sense. I'm sure I didn't need to say that. It's very obvious. Anyway, let's create another order. Let's say Lemmy kill Mr. Probably spelled his name wrong. And we'll create an order for good old Lemmy. And again, events created, all looking pretty good. If we get order summaries now, we have an order for Lemmy in there. And again, let's test this like that. And there we have it. Okay, so we have eventual consistency now. So we've got one more section to go. And basically what we're going to do is not change any functionality. We're just going to take out our self-rolled stuff and replace it with MediatR. I feel you've heard a lot about MediatR being mentioned in relation to CQRS. One of the points of this video, as I'm sure you can see now, is you absolutely do not need MediatR to implement CQRS. Absolutely do not need it, okay? But whether you want to use it, that's a decision for you. And maybe once we use it, you'll go, oh, actually, yeah, I like it, I'm going to use it. Okay, anyway, we'll do that in our final section. So yes, in this final section, we are going on to look at MediatR and implementing that within our application. So let's take a look at our architecture. Now, in fact, the actual overall architecture is pretty much the same as what we just left off with, pretty much identical, to be honest with you. I'll call out one small difference, but other than that, structurally, it's the same app. Functionally, it's the same app, but you can see there's lots of implementational detail changes because we've introduced MediatR. So most especially, you can see over here in our DI container that all the interfaces we defined, well, not all of them, most of them, iCommand handler, iQuery handler, event publisher, and event handler, they're all gone. We don't need those anymore because they're all replaced by MediatR. And you can see that in action when you look at the create order command handler. It's actually now implementing the iRequest handler interface, as are our queries as well. Okay, that's a MediatR supplied interface. Likewise, with our projection handler, it's now implementing something called an iNotification handler. Okay, we also need to change our commands and our queries and our events to implement, well, certainly in the case of commands and queries, we need to implement something called iRequest, and in the case of an event, it's something called iNotification. All right, now the main architectural difference is the fact that, unlike with our previous iteration here, we had our own dedicated in-process event publisher class. With MediatR, we simply leverage a method that MediatR provides to us called publish, okay? But it works in a very similar way. All right, so let's get going. So the first thing we'll want to do in a project is actually add MediatR as a dependency or as a package. So .NET add package MediatR, spelt in that strange way. Now, I probably should have actually mentioned what is MediatR. Why are we even thinking about using it? Well, when you talk about CQRS in the .NET domain, MediatR is almost just slotted in there immediately as the de facto way to do it. And as you've seen with our tutorial so far, you don't need it to do it at all, but it does do a lot of the heavy lifting for you, as we will see now when we actually implement it in our application. So I just want to make the point that it's not needed to implement CQRS, but it can be used to do so, and it does a lot of stuff for you, okay? And it is certainly highly popular. Now, the reason why I kind of made a bit of a Freudian slip there and said it was popular is because fairly recently it moved to requiring a commercial license if you're using it in that context. So you have to pay for it now if you're using it in a commercial project, which, you know, has upset a few people in the .NET space. And for other people, it's like, well, you know, if you value it and you think it's useful, then maybe you should pay for it. I'm on the fence, I'm not going to get too involved. I can see both sides. Anyway, back over to our app, you can see that that's now been added, which is cool. And so let's just wire it up into our dependency injection container. So builder, services, add MediatR, write some config. So CFG goes to CFG, and we'll say register from assembly, register services from assembly, and its type of program. It's just assembly. That. And so what this basically does is that when the application starts, any classes that are implementing mediator related interfaces, it will kind of wire them up for us. Okay, so it kind of does all that heavy lifting again for us. So let's save that off. And we will be revisiting our program class when we come on to updating our endpoints and doing one or two other things, but that's all we need to do there for now. And then coming back to our architecture, I'll just bring it back onto screen. I'm going to start refactoring our kind of lower level objects. And what do I mean by lower level objects? I'm talking about our commands, our queries, and our events. Okay, so we'll start with those first, and then we'll move on to our handlers, and then we'll finish off with our endpoints. So let's start with our command. And all we really need to do here is just implement an I request interface of returning a type of order DTO. Okay, that's it. Okay, so Mediator just requires this interface implementation, and we're telling it that we expect an order DTO to be passed back. Let's come down to our queries. So get order by ID query, exactly the same thing, almost. I'm going to change this slightly. So implements I request of type order DTO. I'm going to suggest that that could be nullable because we might not actually get one. Okay, so I think that makes sense. And then in terms of our commands and our queries, our last query is this one. Again, likewise, and implements I request. And this time it's of type list, and it's a list of order summary DTOs, like that. Okay, so that's our commands, or a command, and our queries done. And then we did also say we needed to update our event, which is definitely true. So our order created event, we simply say that that implements the I, excuse my typing, I notification interface. Okay, so notifications in Mediator are kind of analogous to events, and yeah, maybe I didn't labour the point. Wrong one. A command, yeah. A request can mean a command or a query. Okay, so it's more generic terminology when you use Mediator. Don't forget to save everything that you've done, of course, otherwise we'll run into issues. And we can come on now to actually updating our handlers. So let's start with our create order command handler. So up here, the kind of principal thing we're going to do is remove our reference to our old I command handler and replace it with a request handler. Again, this is something from Mediator. Let me get rid of the command line. It's complaining because we've not implemented that interface. So if we actually do that, you'll see that this is very similar to what we've already done. Okay, so we are returning, we've got a method called handle async, and Mediator requires one called handle. Okay, but it's exactly the same, other than the fact it also expects a cancellation token. So I'm just going to copy this, cut it, and I'm going to paste it in here, leaving in the async keyword, and let's take this out. Okay, so this has implemented the interface that Mediator expects. Before we rectify the issues in here, we also want to get rid of this event publisher stuff because that's all gone now. We don't need that anymore. Mediator takes care of that for us, so we can get rid of that. But what we do need to do, because we are using Mediator, is in here we need to make reference to Mediator. We need to inject an instance of it. So let's get rid of our I event publisher and replace it with I mediator, and we'll call that Mediator. And then we'll have a private read-only variable called underscore Mediator, and we make that equal to Mediator. And then we just need to include that up here. Excuse the typing. Mediator. I've got Mediator. Like that. Okay, cool. So then moving down into our actual method, we need to just obviously update a couple of little things here. The validation is by and large exactly the same, but you'll notice that the other difference in our signature, method signature, is that our create order command is now called request. It's not called command anymore, so we just need to replace that in a few places. In fact, I'll just copy that. And the other thing we can do, in fact, here is pass in the cancellation token. we will do. Okay, other than that, the validation stuff is exactly the same. Down here we're creating an order. Functionally, again, it's exactly the same, but we're just renaming effectively what was our command with a more generic request terminology, and adding it to our database, exactly the same. Passing the cancellation token, and also with our save changes, we pass in the cancellation token. We create our event, construct our event in exactly the same way, but the way we publish it is different. So let's just comment this out so you can look at the differences, and we'll await on our mediator, and we'll simply call the publish method, and we'll publish our order created event like that. Okay, and that is a kind of like for like replacement now, and everything else is exactly the same. All right, cool. So again, looking at our architecture, we've done our command, we've done our handler, we've done our event, we've just used that publish method. Let's just finish off that kind of side of things, our command side of things, by updating our event handler basically to use the mediator notation. So let's come down to our projections, and up here you will change that to I notification handler. Okay, and it's using exactly the same order created event. Again, it'll be a similar. I suppose it's a problem or issue. It won't have the same method signature that we were using before. So instead of handle async, it's handle. So exactly the same concept as before. Let's just cut that out and let's replace this. And of course, what that also means is we no longer have an event called EVT. We have this thing called notification. Okay, so that's okay. We can fix all that up, no problem. And what's the issue here? What's it saying? Let's see what we've done wrong. Let's try that again. I can't see what I did wrong there. So let's maybe I didn't copy some keyword. Let's just cut that out. Maybe that's what it was. Paste that in. I think that's what I did wrong. Didn't have the task keyword. Okay, that's better. Yeah, I shouldn't have got an error there. It was very straightforward. So yeah, all we need to do now is copy this notification and just replace it down here. Replace EVT with that. Do this one. Do this one. Fantastic. And we can pass in the cancellation token here as well to do that. And we can also do that here as well. And that's it. So this one was pretty simple, to be honest with you. You really just have to change the method signature a little bit, and change what we're implementing, notification handler. So that was that one, pretty straightforward. So let's come on and do our queries now, query handlers. So let's do our get order by ID query handler. So again, we no longer are using the iQuery handler that we created. We're going to use again the old request handler provided by MediatR. So let's just implement that interface. You can see it's pretty much, same deal really. Let's just copy it from here, cut it out, and we'll paste it into here, leaving the async keywords, and we'll delete this, like so. And the only thing I want to do, just like we did with our query, is suggest that this is nullable or could be nullable. Okay, so question mark there. You need to replace the term query with request. Otherwise, it's pretty much the same. But one thing I do want to do is I just want to add another, I guess, directive here. Says as no tracking, okay, because the whole point of what we're doing here with CQRS is optimizing for reads and writes, and so by suggesting that we don't need any tracking on our read operations may slightly improve things. Okay, so that's all that's really doing there. And yeah, we're getting these null warnings which drive me crazy. I don't know about you, so we'll just say that can be nullable, which is fair enough to get rid of that. Otherwise everything is exactly the same, so that should be okay. Let's save that off. And then our last handler is our order summaries query handler. And likewise, we are no longer using iQuery handler, we're now using iRequest handler. We'll implement the interface, so control period, implement interface. We will, here we are here, yeah, we'll cut this, X, paste it in here, like that, get rid of this, like so. And likewise, with our previous query, we can also use this as no tracking stuff. So we'll just put that in before the select statement as no tracking. Okay, cool, to optimize that. And that's all we need to do with that one. That one was pretty straightforward. Although what we can also do is actually just put the cancellation token in there just because we're been given it, so why not make use of it? Otherwise, exactly the same. Alright, cool, so let's just take a quick look at our architecture. I think we've done everything other than our endpoints. Let me just take a quick scan of it. Yeah, I think everything's accounted for. As you can see, there's actually quite a lot of code changes here, so we do need to be careful. And I suggest if you're having problems, you're having issues with, when you're doing this, remember the code is on GitHub and you can just pull it down and take a look at it there. Alright, so all we need to do now is come back to our program, and we'll actually see a few things happening here. All this stuff is now kind of invalidated for various obvious reasons. So it's a good opportunity now to clean up these registrations. So the first one I'm going to do is this DB context. Now this has nothing to do with what we are doing right now. In fact, moving to MediatR, that's something I should have taken out in the previous section when we split our databases. So we'll take it out now. And we'll take out all these other ones that we just don't need, the ones that are conveniently erroring out. Take them out. And we don't even need this event publisher. And we don't even need this either. Okay, so all we need are 4 registrations: our read DB context, our write DB context, and our validator and MediatR, of course. Alright, so all that needs to be done now is just update our endpoints and we're good to go. So let's start with the more simple one first. Let's start with this one here, where we're just getting orders by their ID. All we need to pass in here, and this is where it looks a lot simpler, is we can take all of this stuff out and just pass in an MediatR called MediatR. A lot simpler looking. And down here, we no longer obviously have a handler. So what I might do is just comment this out so you can see what it will look like. Let me change it. So we'll say var order equals await. And MediatR, and we use send to send a new get order by ID query using the ID. Okay, everything else remains the same, so I'm sure you'll agree that looks a lot cleaner, a lot nicer than what we had. Okay, a lot nicer. So then let's come down to this other query. We'll just finish that off as well. That's even easier, or even simpler. We just take out all of this stuff and just inject an MediatR called MediatR. And again, rather than handle or async, let's take that out. I'm not going to bother doing the commentary on that. You've seen it all already. We'll use MediatR, send new get order summaries query. So you can see straight away, I have to be honest. Let me just take all of this now as well. It does look significantly cleaner. Now obviously we could maybe cleaned up our own self-rolled stuff as well, but again, this is just the convenience of MediatR. And then finally we'll do our command. And not surprisingly, we can take out all this stuff here. And we just pass in a MediatR called MediatR. And down here, where we want to create our order, we take out this. And we just use our MediatR instance and we send our command. Okay, everything else remains the same. So yeah, definitely a lot cleaner looking. So you can start to see where all the heavy lifting is being done by MediatR, and it's a lot simpler. Okay, so if you're going to implement CQRS, this is definitely something to bear in mind. All right, a lot of code changes. Clear the screen. We'll do a .NET build, but the real proof of the pudding will come in running it. So let's just see the build is clean. We'll do a .NET run. And we're just testing Bruno. And again, functionally speaking, there should be absolutely no differences. It's exactly the same from a consumer perspective, which is exactly what we want, really. So back over on Bruno, let's get an order. So all that stuff should still be there. Yep, Lemmy's there. Let's get our order summaries. Let's just add an order. Let's add, who can we add? Oh, someone who's just passed away recently, unfortunately, Ozzy Osbourne. Probably spelled his name wrong as well, sorry Ozzy. And we'll get all our order summaries. And it brings back our two orders, fantastic. So that is swapping out MediatR for our self-build stuff. Does look a lot simpler, a lot less stuff that we need to do, but again, it depends on your take about which approach you'd like to take. Anyway, that brings us to the end of this video and the end of this tutorial. Thank you so much for joining me, and I'll see you again very soon. Until then though, take care of yourselves, and yeah, take care.